Hey there, calculators. It is math time. I'm Mr. Leavenworth, proud representative of the Calc AB team of Miss Gogerty, Miss Jarosik, and myself. Wanted to take you through a few of our skills that we're going to be learning and a few of the types of problems that you're going to see starting now and all the way through our AP test in May. If you don't have the sheet that you see in the video here, it's attached in the description below. By all means, print it out. Save a copy for yourself, or if you're don't have those capabilities, you can work on a separate sheet of paper if you like. These are some notes of the different sections and things that we've kind of talked about or will begin to talk about, 2.1, 2.2, and 2.3 in our textbook. Those numbers are only just sections. The different things and the different learning targets you'll need are kind of on this top sheet. We've already talked about average and instantaneous velocity. We've talked about graphically and maybe even numerically evaluating a limit. We've done that through a Desmos activity and in class. Today we're going to talk about steps 3 and 4 that you see here, about how to substitute into a limit and maybe some other methods of solving algebraically. We're going to get going, and if you'd like to pause this video at any time, rewind this video at any time, that's a lot easier than me just repeating myself over and over and over again. These problems here on the second sheet, or the second page, number 1 and number 2, are meant to be a review or practice from the graphical limits that we've done prior to you watching this video. But we're going to take it off right here with number 3a. We have a rational expression here. Maybe you remember this from Algebra 2. And these can be a pain to graph. And that would be one way to find a limit. We could always graph this and kind of use Desmos or our calculators, or even graph by hand. If you're feeling really up for it, you could totally do that. But algebraically, the first thing that we should try when we're evaluating a limit, if we don't want to go through that whole graphing process, and in many cases we don't have the time to do that, we can just take this value here and plug it in everywhere we see that particular variable. So if I wanted to say the limit as x approaches -1 of this rational expression, all I would do is I can say that that is equal to -1 to the third minus 4 times -1 squared plus 2 times -1 minus 3 all over -1 plus 2. And you will see that everywhere there was an x, just kind of reviewing those substitution skills, I have a -1 there now. And then again, I can just go through and hopefully without a calculator be able to deal with this pretty simply. So I have -1 minus 4, 1 squared is +1, -2 times -1 is -2, minus 3. -1 plus 2 is a +1. Cool. So that means I really don't even need that denominator anymore. So my limit as x approaches 1, or -1 of this entire expression here is just -1 minus 4 minus 2 minus 3. And that just ends up being -10. And sometimes evaluating a limit is just that simple. Cool. We're going to do a couple more together. Sometimes radical expressions pop up just like rationals do. And as long as your x value or your limit value that you're plugging in doesn't break the radical, we can do the exact same thing. So maybe you could even pause the video right now and try letter C before I go over it. Go ahead. Like seriously, pause it. Like right now. Go ahead. I'll wait. Okay, welcome back. Whether you pause it or not, we're going to go over letter C right here. And again, we have our variable and we have a value that we are approaching graphically, but we can also find that algebraically. And I'll just kind of rip through this real quick. We're just going to plug that 1 in everywhere we see an x. So that's the square root of 1 plus 8, which is the square root of 9, which is, hey, that means that if our limit as x approaches 1 on this graph, we should be approaching a y value of 3. Awesome. One more, and then we'll be done with the video for tonight. Here we go, letter F. Here's what I want to do. You probably can just go right ahead and do it. But here we go. We're going to take this -1. Everywhere there's an x. So here we are. -1 squared minus 5 times -1 minus 6 all over -1 plus 1. Oh, ooh, maybe you see the problem. Let's keep going. 1 plus 5 minus 6 over -1 plus 1 is 0. Oh, that's bad enough, but check this out. 1 plus 5 minus 6 is also 0. Crap. I don't know. Do you know what we do with this yet? Have you seen problems like this? Stay tuned for the next video to find out. See you guys. Wakanda forever.